Zöld Lámpa. Ön a Klímapolitikai Intézet podcastjét hallgatja.
Hello everyone, welcome to Green Light, the podcast series of Climate Policy Institute. Today's guest is Dr. Michael Beckmann, Professor for Energy Process Engineering, Director of the Institute for Process Engineering and Environmental Technology, as well as Dean of the Faculty of Mechanical Engineering at Dresden University of Technology. Professor Beckmann is author of more than 300 studies and an acclaimed expert of the German energy sector. Professor, thank you for being here with us today.
Hello.
So my first question concerns the energy crisis that has been going on for a few years and the EU's responses to it. The energy crisis itself has been going on since before the Russia-Ukrainian war, but has been aggravated by the conflict. This resulted in different responses in different parts of the EU. And I would like to know what the main lessons are that each member state must learn, regardless of size, location, energy mix, and former relations to Russia.
Yeah, I think first of all, this is a responsibility. So in all member states, we are responsible for the generation of a secure supply of energy. We see that energy is, we can call it the blood of our society, and we are strongly dependent on on a secure, safe, environmental safe, and also economic available supply of energy.
Yes, I think we can all agree to that. But could you give a few examples on the uniformity of the lessons all member states must learn? I mean, there are lessons to learn for every member state, I guess, depending on their distance from Russia, their former relations to Russia, and their former energy mix. But is there a lesson to learn for each and every one of the EU member state, regardless of all these factors?
I think this is not a question we can answer generally for all member states in Europe. So because we have a different energy mix each country, and so we are more or less dependent on fossil fuels in our European member states. And so in Germany we decommissioned the nuclear power just in this year. So I think there are different situations, and we have to look carefully to each member state and to the different energy mix in these member states.
Okay, speaking of differences, I would have specific questions regarding your home country, because that might give us a more precise and more focused answer. So I would like to know, and I would like to ask you as an expert of German energy production, how would you evaluate your country's energy mix before the war? And what are your thoughts on Berlin's reactions for the war and the energy crisis?
Yeah, the situation just before the war in Ukraine was that we had the possibility to get Russian natural gas, also oil from Russia, and our so-called Energiewende or our energy turnaround was strongly dependent on the supply of natural gas, because we increased or we are still increasing our so-called renewable energy part with wind energy and solar energy. But these are fluctuating energies. So if there is a dark calm, for instance, then no energy is supplied to the grid from wind and solar power. So we need backup capacities. So our aim, the objective, is to reduce CO2 emissions, of course, and with this aim, the fossil coal power plants. It was intended to phase out from the coal to reduce CO2 emissions from coal power, and instead to increase the power plants for backup, for the difference of supply from natural gas power plants. But this is now still a problem, and what we see in Germany at the moment is, after phasing out also or shut down the nuclear power in April 2023, due to the demand of electricity, we have at the moment coal power plants are still increasing again, or the production from coal power plants is still increasing again, and with that CO2 emissions are not reduced, but if we look to the energy sector, they are increasing at the moment. So this is the situation.
You've been mentioning nuclear energy a few times, and my next question's aim is to clarify a few notions and a few misconceptions and maybe a few common beliefs concerning nuclear energy. Most people, like myself, don't know much about the distinctive features of different generations of nuclear power plants or nuclear reactors. So how would you describe the main differences between generations 1, 2, 3, and 4 of nuclear power plants, as well as small modular power plants, from a security and efficiency point of view, and also an environmental point of view, because I think all three are very important and of major concern for most people opposing nuclear reactors. So from a security, an efficiency, and an environmental point of view.
Mm-hmm. Yeah, I must say just before, I'm not an expert in nuclear, in the field of nuclear energy, so I can give you only a general answer here at
that's
this point.
That's what we're looking for, so that's perfect.
What I know from this field and also from my colleagues is that the generation 4, you mentioned it. This is under development, 4 and 4 plus, and I think we will get the first practical and industrial reliable results within the next few years. We will obtain it, and with that, it is possible to use the so-called radioactive waste, or the waste material from reactor generation 3. So if we look to Germany, then so we have for the next, this is my information, for the next 150, 200 years, enough energy resources to operate this generation 4 plus. So what I think from a general point of view is that we had the first nuclear fission in 1938, if I remember right. So this is just not 100 years. And in the 1950s, we had the first nuclear power plants in operation. So this is not a long history if we looking back, and we have to take into account that there is still a very huge potential for innovation, for development, and this potential is not exhausted yet. So what we should recognize is not to say, okay, maybe from our perspective today, nuclear power plants, they have a problem with radioactive waste material at the end and so on, but we must look forward to innovation to the development, what you mentioned, generation 4 plus, and we should recognize that there is potential, a huge potential for development where we can use in the next generation this today waste material we can use in the future. And so in this response, you've been discussing
efficiency and environmental perspectives of nuclear energy production and nuclear waste. And these are important aspects, but also for most people, most opponents of nuclear energy, the security aspect is probably the most significant one. So what would your comparison be for different generations of nuclear power plants in terms of security?
Yeah, in terms of security, I cannot give you numbers because what I mentioned, I'm not an expert in this field. So, but what I want to mention, and I forgot it in the last in this last question, the environmental aspects, of course. So, if we are looking for a reduction of CO2 emissions, and if we are looking to an economic viable way to produce energy and to produce a secure supply, then of course this, to my mind, this could only be possible with an energy mix of a certain part of so-called renewable energy, wind, solar power, of course, in combination with production of hydrogen or ammonia, and so for storaging or for chemical issues and so on. But then we need a base load from nuclear power. So this is what I think.
A base load is needed until we cannot fulfill our energy needs from different sources. So my next question is on the coexistence of nuclear energy and the renewable energy sources. In the EU, there is no consensus on nuclear energy, but in many other parts of the world, nuclear power plants are being built extensively. And I would like to know if we will still need nuclear energy a few decades from now, if the sufficient storage capacities for renewable energy sources are installed, and if highly developed weather forecast systems, along with carefully planned energy networks, make renewables more effective.
Mm-hmm. Yeah, I think this is a long way which is necessary to develop such a system. You mentioned it, renewable or fluctuating wind power generation on the one hand side, and possibilities for storage in kind of chemical or in all types of storage, from batteries for short term, but also for long term, and for chemical issues or material issues in chemical storages. If we consider the development of technical processes, then we have taken into account the so-called technology readiness level. This is an evaluation coming from the NASA, and it means one is the idea maybe of an aeroplane or of a flight object, and level 9 is that this plane can start, it can take passengers with it, and it's possible to land safely. So if we transfer it to our energy system and to the storage, for instance, storage, I mean the complex of electrolyzers, the transformation from electricity to hydrogen storage, and reconversion, maybe hydrogen via turbines to electricity. So this whole complex, together with the controlling of the grid, this we should keep in mind. It's not only a single power plant. It's the controlling of the whole grid to obtain a stable grid frequency. Here, we can say at the moment we are on a technical readiness level, TRL, of about 4 to 5. So we are in a midterm, and this is not a question of 2, 3, 4, 5 years. I think it's a question of 1 or 2 decades we need to enroll this system, if it is possible to enroll this system over over a certain country or in a certain region.
But if we were to reach technological readiness level 9 in terms of not only renewable energy sources, but also storage capacities, weather forecast, and the system and the grid that always transfers energy to places where it's lacking, do you think it would be possible to phase out nuclear power plants like Germany does right now? Maybe not at a readiness level of 9, but in the future, a few decades from now, do you think it could be possible?
Yeah, I think just before we phase out our conventional power plants, which we need for a secure supply, and also for a safe and economical supply of energy, we have to make sure that the new generation system is reliable in operation. I think this is this is a very important precondition. We cannot phase out just before we have a new base load or a new energy system in operation.
And my final question is a bit of a clickbait maybe, but I would like to know, if you were appointed, let's say tomorrow, to shape the EU's energy mix to your liking, what would your first 3 steps be?
Yeah, I would say the first step is to open a scientific-based debate about the reliable way for the further development. I wouldn't say for the transformation, because transformation is a really strong word. I would say for the development, because this includes more a liberal innovation way. Yeah? So first of all, I would open such an scientific-based debate.
You think that's missing right now? So that's not present?
I think this is missing right now, because this is too much in an ideological way. So we are debating about better or not so good, or if nuclear power is from the ecological point of view good for the energy mix or not. So I think this is not really, the debate is more influenced from our objective in 2045, 2050 to become or to reach this objective of zero emission. So, and this is the focus is too strong on this objective, and from if we only discuss from this end point, then of course, we have too less leeways. Yeah. The second point is I would develop or would put my energy into an more homogeneous, uniform energy mix and energy supply, energy grid in Europe. So this is at the moment, so I have the feeling that each single member state has his own philosophy, has his own energy mix and strategy. So what we need for our European community is a common system and a common market for energy supply, energy delivery. Yeah, and the third point is, of course, I would spend money for development in the field of science, not with so strong boundary conditions. Yeah, not with to give such boundary conditions that we will spend only money for one or the other technology. I would also open the scientific development a little bit more than this is now the case.
Thank you very much. I could ask you many more questions because this has been a very interesting conversation, but unfortunately our time is up. So thanks everyone for listening to Greenlight Podcast today. And Dr. Michael Beckmann, thank you very much for being here with us today.
Thank you very much for inviting me, and all the best.
Zöld Lámpa. Ön a Klímapolitikai Intézet podcastjét hallotta. További tartalmakért látogasson el a klímapolitikaintézet.hu honlapunkra, és kövessen minket a Facebookon és az Instagramon.